Inorganic Chemistry, Round 1, Part 3. Nuclear magnetic resonance (NMR) spectroscopy is a resonance technique involving absorption of radio frequency energy. The magnetic environment of a nucleus affects its resonance frequency and allows structural information to be deduced. More positive or less negative chemical shifts equals higher frequency, which equals downfield. Less positive or more negative chemical shifts equals lower frequency, upfield. The number of spins of the attached nuclei determine the multiplicity, number of lines, and patterns of the NMR spectroscopy signal of the observed nucleus. The coupling constant between the nuclei X and Y is denoted as JXY and is measured in Hertz. Multiplicity, number of lines, equals 2NL plus 1. Nucleus being observed is coupling to N equivalent nuclei with quantum number L. Electron paramagnetic resonance (EPR) spectroscopy is a resonance technique involving microwave-induced transitions between magnetic energy levels of electrons which possess a net spin and orbital angular momentum. An EPR spectrum provides information about paramagnetic species. The Mossbauer effect is the emission and resonant absorption of nuclear gamma rays studied under conditions such that the nuclei have negligible recoil velocities when gamma rays are emitted or absorbed. This is only achieved by working with solid samples in which the nuclei are held rigidly in a crystal lattice. In X-ray diffraction, XRD, X-rays are diffracted by electrons surrounding the nuclei in atoms in a crystalline or polycrystalline solid. Analysis by single crystal X-ray diffraction leads to the full determination of the structure of a compound. Single crystals suitable for X-ray diffraction can be grown by a number of methods, all of which lower the solubility of the compound in solution. Evaporation of solvent from a solution of compound, cooling a solution of the compound, diffusing a solvent in which the compound is insoluble or poorly soluble into a solution of compound in a second solvent, allowing the vapor of a volatile solvent to diffuse into a solution of the compound in a second solvent. In addition, it may be possible to grow crystals by sublimation or from a melt. Polymorphs are different phases of the same chemical compound with different crystal structures. A powder is a polycrystalline sample. Powder X-ray diffraction data are routinely used for identifying a bulk sample of a material and for screening different phases of a compound. In neutron diffraction, Bragg scattering of neutrons occurs when neutrons interact with the nuclei of the atom in a single crystal. Both light and heavy atoms can be directly detected. Neutron diffraction is less commonly used than X-ray diffraction because of the limitations and costs of sources of neutrons. However, because the technique relies upon the diffraction of neutrons by atomic nuclei, neutron diffraction has the advantage that it can accurately locate light atoms such as hydrogen. Before a beam of neutrons from a nuclear reactor can be used for a neutron diffraction experiment, its energy must be reduced. Neutrons released from fission of uranium-235 nuclei lose most of their kinetic energy by passing through a moderator such as heavy water, D2O. It follows from the de Broglie relationship that the energy of the thermal neutrons so produced corresponds to a wavelength of 100 to 500 picometers, 1 to 5 angstrom, i.e. appropriate for diffraction by a molecular or ionic solid. The scattering of neutrons follows Bragg's equation, and the diffraction experiment is similar to that for X-ray diffraction. In gas phase electron diffraction, electrons are scattered by the electric fields of atomic nuclei and gas phase molecules. Intramolecular bond parameters are determined. In electron ionization mass spectrometry, ions are produced by bombarding gaseous molecules with high-energy electrons. It is a hard technique and causes fragmentation of the parent molecule. Fast atom bombardment, FAB, mass spectrometry. Ions are produced by bombarding the sample. neutral molecules are ionic salts with high energy xenon or argon. It is a soft technique and usually causes little fragmentation. In matrix-assisted laser desorption ionization time of flight mass spectrometry, a UV laser is used to generate atoms M of the sample M plus H plus or M plus Na plus. Ions are typically detected. It is a soft method and there is little fragmentation. In electrospray ionization mass spectrometry, ions are formed from a fine spray of solution under applied electrical potential. It is a soft technique used for both neutral molecules or ionic salts. Singly and multiply charged ions are observed. Koopman's theorem relates ionization energy of the atomic or molecular orbital in which the electron resides before ejection. Thus, bonding energies measured from PES give a measure of atomic or molecular orbital energies. The application of PES can be diversified by using different irradiation sources.